Hi, grade nines. Welcome to chapter 9, which is titled Linear Inequalities. And the first thing that we're going to do today is represent inequalities. I haven't heard this before, what an inequality is. So the first part of this lesson is just identifying what an inequality is and doing a little bit of work with that, not solving any inequalities yet. So you can see at the top of the page, the objective is to represent single variable linear inequalities verbally, algebraically, and graphically, and then to determine if a given number is a possible solution of a linear inequality. So those are the two things we're going to do today. First of all, an inequality, all that is a mathematical statement comparing expressions that may not be equal. What we've been doing up to now is solving equations, and in an equation, what we've got, let's grab a pen here, an equation compares expressions that are equal. So when you solved an algebraic equation in chapter 8, you ended up with something like, you ended up with an answer, for example, we ended up with x equals 2. And there's only one solution to that equation, and that solution is 2. It could be nothing else. Inequalities, we can have more than one solution to an inequality. And at the bottom of the page here is just an example of what inequalities look like. So if I look at these ones here on the right-hand side, these are all, once we get to solving inequalities, that's what your solutions will look like, something like that. And it's just understanding what they mean is the first part of this lesson. So a lot of these symbols you've probably seen in previous years. For example, if I grab this and drag it down here, that's an inequality. What that says is x can be any value that's greater than 4. So not just one solution. Anything that's greater than 4 satisfies that inequality or is correct. Okay, so x greater than 4 could be 5, could be 7, could be 10. So x can take on anything that's greater than 4. So if I look at the verbal description and I find x is greater than 4, that would be x is greater than 4. And if we gave an example of a value that is greater than 4, 4.2, 17, those are all greater than 4, so those work. The other symbol you're familiar with from elementary school even is this one here, which is x is less than 4. So anything that is less than 4 satisfies that inequality or makes it true. So 1, -5, anything less than 4 works. Now the two symbols that you haven't seen before would be this one here, which I just grabbed, and we have a greater than symbol with a line underneath it there. And all that means, and if I look up these choices, well, that looks to me like it's going to be x is greater than or equal to 4. Now, the difference between this third one and the first one we did, in the first one, x is greater than 4, has to be anything bigger than 4. It cannot be 4. Okay. In this one right here, x is greater than or equal to 4, so it can be anything from 4 and up. So that's that one. This one here, x is less than or equal to 4, and that one would go there. And the other ones here are really more the same. We just have a decimal value. So again, here, x is greater than -2.3. So any value greater than -2.3 works there. X is less than -2.3 would be there. And I can finish this off taking this one and this one. This one is x is greater than or equal to -2.3. X is less than or equal to -2.3. So those would be the verbal descriptions, and these are inequality statements right here on the left-hand side. So you can see if we're going to give examples of these, we could write unlimited numbers of examples. X is greater than 4. We could list endless numbers that are greater than 4 that would satisfy that inequality and so forth. So these are just right here. This is what an inequality looks like. When we eventually get to solving them, that's what your answer is going to look like. These are just verbal descriptions of that algebraic statement. So that's all inequalities are. And if we go on to the next page of these notes, this just again is showing this is the greater than symbol, less than symbol, greater than or equal to, less than or equal to. And here's an example of each of those things. All right, so one thing that you have to do is you'll be given a verbal statement and asked to write an inequality that means the same thing. So you're going to be given a verbal statement like an A, where it says this person named Rima here, and it says that she earns overtime pay when she works more than 40 hours. So according to the statement, she has to work more than 40 hours to get overtime pay. Working 40 hours doesn't get her overtime pay, but anything over 40 hours would. So if I was to write an inequality statement for that, let's say I could use any variable I wanted. So let's say I use T for time, and she's going to get overtime pay when she works more than 40 hours. So her time has to be greater than 40. So that's the inequality statement that represents that verbal statement. In part B, in Alberta, you must be at least 16 years old to get a driver's license, which is true. And so my age, I can be 25 and get a driver's license. I can be 17 and get a driver's license. I can be 16 and get a driver's license, but I can't be 15. So my age has to be greater than or equal to 16. So that would be the inequality statement or algebraic statement for that inequality verbal statement. Part C, in the NHL, no hockey stick can exceed 160 centimeters. So the length of the hockey stick has to be 160 centimeters or less. Can't be anything over. Okay, it can be 160, but not anything greater. So if I'm talking about the length of a hockey stick, that length has to be less than or equal to 160 centimeters. D, the time spent on the activity can be at most 13 minutes. So my activity time can be 13 minutes or anything less. It can't be anything over 13 minutes. My activity time is less than or equal to 13. Okay. And E, to ride California Screamin', you must be at least 40 inches tall. So my height to ride this roller coaster as an inequality, I have to be anywhere from 40 inches and up. So my height is greater than or equal to 40. So that's just writing inequality statements based on verbal descriptions. Now, the other thing that you have to do with inequalities, besides writing a verbal, not a verbal description, but an inequality based on a verbal description, is we have to graph inequalities. And I wouldn't stress too much about what a graph looks like with this. All a graph of an inequality is a number line. So you don't have to set up an X and Y axis or use graph paper or anything like that. We just have to represent this on a number line. And two things that we have to be aware of are something called boundary points. Boundary points are the number in the inequality. So for example, in A, my boundary point is 5. In B, my boundary point is negative 3.5, and in C, my boundary point is 25. So that's the boundary point they refer to. And in this one here in A, it's asking me to graph X is greater than or equal to 5. So I need to show that on a number line and what that looks like, this inequality X is greater than or equal to 5. Now, one thing that you need to know is with regards to these boundary points, you're going to put a dot on the boundary point on that number line. So that was going to be a dot there. The dot is either going to be open or it is going to be shaded in or colored in, closed. Now, anytime we graph something like in A where it's greater than or equal to or less than or equal to, our boundary point will always be colored in or shaded. This closed circle shows that the boundary point is included in the solution. So for example, x is greater than or equal to 5. What I would do is I would put a boundary point at 5. So I find 5 on my number line, which is right here. And the reason I shade it in is because in this one, x can be 5. It's greater than or equal to 5. And the only other part I need to do besides shading this dot is show which way on the number line that this graph would go. So greater than or equal to 5 would be any value that goes from 5, including 5, and that way. So you've just graphed your first inequality. So this number line shows x is greater than or equal to 5. Again, shaded in dot if it's greater than or equal to or less than or equal to. B, x is less than negative 3.5. So in this one here, my boundary point, I have to figure out, okay, well, where's negative 3.5 on this graph for this number line? Well, here's negative 2, here's negative 4. It looks like these might be going up by 0.5s because there'd be negative 2.5, negative 3, negative 3.5, negative 4, and so forth. So negative 3.5 is going to be right here. Now, in this one, whenever we have just a greater than or less than symbol, we have an open dot at that boundary point. And the reason we have an open dot is this negative 3.5 is our boundary point, but it's not part of it. X can't be negative 3.5. It's anything that's less than negative 3.5. And we indicate that on a number line with an open dot. So where did I say negative 3.5 was? Sorry, it's right here. And if I put an open dot here, and x is anything less than negative 3.5, not including it, but less, that's why we have an open dot, and my graph goes that way. And so that's graphing that inequality. And then the last one, now sometimes they'll flip the variable onto the other side of the inequality. I always say, I find it easiest, always read from the variable. So I'm kind of reading this one backwards to me. So I read from the x, and I'm reading this as x is greater than 25. So again, 25 is not part of this inequality, but it is my boundary point. So I am going to have an open dot at 25, which is on this graph right here. So there's an open dot, and x is anything greater than 25. So that, in fact, would be going this way, because I read this as x is greater than 25. Some people like to say 25 is less than x, which you can. I just always find it's easier to read from the variable x is greater than 25. That's any value not including 25 and bigger. Okay, so that's graphing inequalities. Again, all it is a number line. Anything that is greater than, or sorry, less than or equal to, greater than or equal to is always a closed dot. Anything that is greater than, less than is always an open dot. That's all you need to remember with regards to the number lines and graphing and inequality. So we'll practice that a little bit on the next slide. And on this one here, it's tough to tell which way this graph's going, but actually this graph is, and I'll just highlight it, is an open dot right there, and it is going this way. So we're going to now, instead of be given the inequality and doing the graph, we're giving you the graph and asking you to write the inequality or the algebraic version of that. So again, this is an open dot, so 4 isn't a part of this, but it's anything from 4 and bigger. So here, this is going to be x is greater than 4. That is the inequality based on that graph. Verbally, that's x is greater than 4. I will write that up. This graph right here is, we've got a colored in or a shaded in or a closed dot, and our graph is headed that way. Our boundary point right here is, maybe we need to figure that out. Well, here's 0, here's negative 20, so this is negative 5, negative 10, negative 15. So my boundary point here is negative 15, and I'll just write it there, there's negative 15. This is including negative 15, and it's going left, so it's going to values that are smaller. So this algebraic or inequality, algebraic version, would be x is less than or equal to negative 15. And the reason, again, it's less than or equal to is because this is a shaded in dot or a closed dot. That means negative 15 is a part of this inequality. Part C, the only tough part about C is to figure out what's the divisions in this number, or what are the divisions in this number line. So sometimes they kind of mess. It's not always fives or 0.1. In this one, we've got 1, 2, 3, 4, 5, 6, 7, 8 divisions between the 1 and the 2. What that means is each one of these spaces right here, that's 1/8. And if you did that as a decimal, that's 0.125. So actually each of these spaces are 0.125. So it's not a very nice one. And this one, this graph right here is a closed dot, and it's headed this way. So the toughest part about this one was figuring out what the boundary point is. So this is 1, and there'd be a 1/8, 2/8, 3/8. So that's 1 3/8. Or if you convert 1 3/8 to a decimal, that's 1.375. So to write the inequality, again, this is a closed dot. So my x value, now you don't have to always use x, I just always do. You can use any variable you want. X is greater than or equal to 1.375. You could use the fraction if you wanted. X is greater than or equal to 1 3/8. So this number line, and there's the same inequality that represents that number line. Part D, again, find out what the divisions are, or what this boundary point is. Here's negative 15, here's negative 20. I wonder if these are going by ones. 15, there's 16, 17, 18, 19, 20. So this boundary point is negative 17. We've got a closed dot, and my graph is headed to the right, so all values that are bigger. So x is greater than or equal to negative 17. It's all values from negative 17 and up. And then the last one, we have an open dot, and our graph is headed to values that are smaller. Figuring out what the divisions are, it looks to me like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these is 1/10. So this is 2, 2.1, 2.2, 2.3. So my value x is less than 2.3. Now it's not less than or equal to, because this is an open dot. Open dot, 2.3 isn't part of the inequality, so it's anything less than 2.3. And that is, given a graph, writing an inequality, just the reverse of what we just did. The other thing that you'll have to do is you will be given kind of word statements, and you'll have to describe what's going on in a scenario verbally, graphically, and algebraically. So we'll do this one. It's based on this headline here, which I always find interesting because it seems like a lot of water to me. Average daily use or water use per person, 327 liters to 343 liters. To me, that seems excessive. I don't know. Seems like a lot of water, anyhow. But verbally, we can describe what that headline is saying. So what it's saying verbally, and I won't write it down, we'll just talk about it, but daily water use is greater than or equal to 327 liters, and daily water use is less than or equal to 343. So it goes from 327 to 343. So, well, maybe I will write it down. So if I can here. So daily water use is greater than or equal to 327 liters. So that's the first part. Whoops, 327, I guess it should be. I'll fix that. $327 liters. There we go. So average water use from 327 liters. So it starts at 327 and goes up to 343 and that's as far as it goes. So it's from 327 to 343. So the other part of this is daily water use is less than or equal to 343 liters. So that's verbally describing what's going on in the headline. So daily water use from 327, including 327, to 343, including 343. Nothing less, nothing more. Graphically, they've done the graph for you. And here, obviously, in this one, there's two boundary points. So we have starting at 327 liters here, and here's our 343 liters. According to the headline, the daily water use goes from 327 to 343 inclusive. So that's why we have two closed-in dots, or colored-in dots, or closed dots. So it includes 327, includes 343. So that's my inequality, is just a dot here, and then the graph is joining those two dots because it's anywhere from here to here, daily water use all in between there. So that would be the graphic representation of that inequality. So algebraically, to write this, whatever you want to use for your variables, W for water use, we can do this two different ways. We can write the inequality for this first piece, and then write the inequality for the second piece, and then we'll show you how to do it all in one. So water use in the first statement is greater than or equal to 327. So it's greater than or equal to 327 liters. The second part of this is water use is less than or equal to 343 liters. So we can write that as that combination of inequalities is two separate inequalities. That's perfectly fine. The way that they do this a little more in Math 10 is they write it all in one line. So they put the variable for water usage kind of in the middle, and then they'll put this inequality on the left side and this inequality on the right side. And again, always read from the variable. So if I want to write water use is greater than or equal to 327 from the variable, this is greater than or equal to 327, and then less than or equal to 343. This is less than or equal to 343. Again, I always read from the variable. So here's my water use, greater than or equal to 327, less than or equal to 343. You can write this combination of inequalities as two separate ones, or we can put it all in one line and do it that way, and either is acceptable. Let's have a look at the next page, and we'll do a little bit more with combinations of inequalities. I'm not going to do this show up here. I think I'll do, I'll go to this one, we'll graph a combination of inequalities, and then we'll write a couple, so just a little practice that way. So in this one here, we have to sketch or graph the inequalities, or the combination of inequalities of x is less than 28 and x is greater than or equal to 16. So I have two boundary points, and I want to mark where my 16 is and what my 28 is. So if I look at this number line, it's looking like we're going by these twos, 10, 12, 14, 16, 18, 20. It looks like we're going by twos here, each of these. So x is greater than or equal to 16. Again, that will be a closed dot because it is greater than or equal to. Okay, it can be 16. So there's 12, 14, 16. So right there, I would put a closed-in dot. And less than 28. So I find that boundary point 28, but it can't include 28. So in this one here, this has to be an open dot. So now this can be values in between those 2 points. Greater than or equal to 16, that's why it's a closed-in dot, and less than 28. Now it can't be 28, but it can be anything less. So that's on that number line, that indicates those, or that combination of inequalities. Do the same sort of thing with B. We just need to find the boundary points, 2.2, 3.6, and we've got 2.2, 4, 6, 8. These are going by, these are each 2/10 or 0.2. So 2.2, x is greater than 2.2. So again, that has to be an open dot because it's greater than. Can't be 2.2, it's an open dot there. And 3.6, 2, 4, looks like 3.6 is right here. And it can be less than or equal to 3.6. So here I would join those two together. This is showing that this value, x, can be greater than 2.2, but not 2.2, and is less than 3.6, and it can be 3.6. So that would be a combination, or graphing a combination of inequalities. Just the flip side of this, or same sort of concept, is we are going to write the combination of inequalities represented by this number line right here. And this number line is going from here to here. And it looks like those are both open dots. So we've got an open dot here, and we have an open dot there. This is 3 on the number line, and that is 9. So we've got anything that's greater than 3 and less than 9. And it can't be 3 and it can't be 9 because they're open dots. So again, I can write this as two separate inequalities. X is greater than 3, and x is less than 9. So that works. That's the combination of inequalities. Or I could do this all in one line. And with that one, again, I put my x in the middle. And this is greater than 3. So always read from the variable. So x is greater than 3, and x is less than 9. That would be all in one line. Those mean the exact same thing. Either one's fine. Last one, we've got a closed dot here at -20, and we've got an open dot here at 10. That's supposed to be an open dot, and we've got a line in between. Combination of inequalities. This is x, anything from -20, and this is getting bigger. So this is x is greater than or equal to -20. Whoops, 20, because that is a closed-in dot. And this one is an open dot at 10. X is less than 10. Less than 10. That's what that's supposed to say. If I wrote that out as a combination, x is greater than or equal to -20. Again, always read from the variable. X is greater than or equal to -20. And x is less than 10. So that's all 9.1 is. I know that was pretty long, but it's just writing inequalities for word scenarios and then graphing inequalities. And you just need to understand what an inequality is, and that it can take on different values. So with that, there should be a short assignment on 9.1 just to practice writing inequalities and graphing them. And then 9.2 and 9.3 are actually solving inequalities, and that is no different than solving algebraic equations. So it should go fairly straightforward with regards to solving the inequalities. It won't be too bad. But if you have any questions at all, as always, get a hold of us, and we'll be in touch. So good luck. Take care.